Hey y'all. So this video is all about how to deal with dates and times in R. Specifically, we're going to be using the Lubridate package. So if you don't already have it installed, you know what to do. Install that packages, give it a shot. I do have it installed. Have it Lubridate at the top and go ahead and load that. If you want to know more about the package, you also know what to do. Question mark package name. Essentially, what Lubridate is it's a bunch of convenience functions for dealing with dates and times. For a variety of reasons, dates and times are kind of complex in R. Mostly, it's not a big issue. Dates and times are kind of complex in all statistical programming, frankly. Most of the time, we're dealing with fairly simple stuff. For instance, we're not dealing with like hyper detailed like time data along with dates in different time zones and all that. So generally you don't have to have like a super detailed knowledge of this if like your data is on like a yearly scale or like a day scale or something like that. But just know that sort of any amount of like idiosyncratic time measurements are possible. There are three basic time classes in R. We talked a while back about how there's only a few different like canonical things like vectors and lists, those types of objects in R. That's still the case here. There's just a couple special things, sort of like how factor is like a special object that just has a few other details on top of an integer object. Similarly, dates and times are still made up of like character strings and numbers, but it's like a special wrapper that has been built around it. And so R recognizes like, oh, we're talking about a date here, not just any old number, or this string represents a particular type of data. It's not just an arbitrary character string. So like the three types of like specialty date object wrappers, one is just called dates. And so that is simply like a year, month, and day. So 4 digits dash 2 digits dash 2 digits. So something like as dot date, and you could make a character string like 2012, 2020, 0101. So this would be January 1st, 2020. You can see it just kind of replicates itself in the test code I did. So if we called this object test underscore date and ran as dot date 2020-0101, we call class on that new object we just created, test underscore date, R in fact does say, hey, this is a date object. Two other classes, and we're not going to spend much time on them, are POSIX CT and POSIX LT. I actually don't remember what POSIX stands for. It's indicating we're talking about like dates and times. Functionally for us, CT and LT are going to be just about identical. They're both cases where we have a date and a time and potentially a time zone stored with it. So year, month, day, hour, minute, second, time zone if need be. R stores CT and LT objects a little bit differently. Explanation is actually kind of fusing. CT stands for calendar time and LT stands for local time, which neither of those make a lot of sense. And you might think local time is like a special time zone. It's not that either. Let's just leave it there. Happy to talk more about that in class. But in general, if you ever see in an error code or you call for some sort of class or function and you see POSIX, POSIX, just know like, oh, we have like a date and time sort of problem here. I'm dealing with date and time objects. So I'm working in the course materials page on the title is called date-times with Lubridate. So I'm going to paste in the first sample code chunk here. And what we're going to call this is an object called sample underscore dates underscore one. And then it's just 5 arbitrary dates in 2018 and 2019. So go ahead and store that object. So now the first thing you might try is, hey, I want to make a date object. So I'm going to go as.date, and I'm going to feed in this vector of character strings that I can see are dates, but R doesn't know they're dates. It just thinks there's arbitrary numbers and dashes. And if we run that, it actually looks identical. That's just sort of a nice feature because you fed in sort of what R was expecting a date to look like. And that's not always the case if you feed in different orders. So let me show you an example here. In this case, let's say we're going to make sample underscore dates 2. And now we're going to say month, day, year. So these are the exact same dates, but now we are storing the month and day and year in different order. And if you were to call as.date on sample underscore dates underscore 2, it doesn't know what to expect because R was thinking, okay, I'm going to find year, month, and then day. And so it flipped out a little bit because it said, you said year 2, you said year 10, you said year 3. Like, I don't understand any of this. And so it kind of flipped out. And so for instance, that's also why, because it was expecting a month as the second number, you got an NA for the second string you fed in, because it was like, I don't know what the 21st month is. That doesn't make sense. So if you tell R to like link up on the 33rd, it's going to freak out because it's going to say, hey, there is no 33rd. I think you are trying to brush me off and say we should never meet. And it will throw an NA instead. Let me show you how you might be able to accommodate that then. So the reason that didn't work, the sample dates 2 call didn't work, is because R was assuming you were giving me year, month, day, but in fact you gave me a different order. So what if we actually try this again and we tell R the order we're feeding things in? So this is going to look a little funky at first. Within the as.date function, you can call this format setting. And what you do in the format setting is you actually specify, here is the, instead of using the default settings, the default approach, here's the order in which you're going to find these objects. And so this will look a little opaque at first. So let me explain what's going on here. The percentage sign is like an indicator. Hey, in this case, this is going to be some sort of like time value. Then we have an M that stands for month, right? You have a D that stands for day, and you have a Y that stands for year. Why are some uppercase and lowercase? So the reason here is that month and day are coming in 2-digit format, year is coming in 4-digit format. This is a lot to remember. It's all kind of weird. It's not really clear why stuff is hardwired and why stuff isn't hardwired. And actually, I guess I should say, I assume the capital Y is because 4-digit format, but I don't actually know that. Let's look at the help file and see if that's the case. The help file does not say anything about this as far as I can tell. It appears to maybe just be convention that Y is a capital letter. Maybe Liza or Tara knows, so we can ask them at some point. In any case, so recall if we just called as.date, it didn't work, but in this case we say, hey, R, I'm going to call as.date, and it's going to be month and then day and then year. Check it out. In this case, if we run sample underscore dates underscore 3, R does in fact parse those correctly again, and because we're coding these as a date object, it turns it into the preferable year, month, day format. Why is that preferable? Because if you were actually trying to sort by time, these are sort of like character strings, right? And so if you store your date object as year, month, day, and then you arrange that, it would automatically arrange in chronological order, or if you wanted reverse chronological order, because it would sort year and then month and then day when it was sort of like alphabetizing these character strings. So to show you 2 other examples, let's say you have slashes, and so you have like year, month, day with slashes in between. You could do that same like percentage sign Y in this case for the order, and then slash percentage sign M slash percentage sign D. And so it's saying, hey, instead of dashes between the numbers, there's going to be a slash. That works. You can even do particularly crazy things. Like let's say for whatever reason, the character A was in between each of your values, right? So you have 05, A21, A2011, and that's supposed to represent May 21st, 2011. Well, you could say, hey, this format is percentage sign M, capital A, percentage sign D, capital A, percentage sign Y. And in fact, if you ran that, you could end up with your date. So 2 ways to sort of treat these data objects. One, you can code in that format and say, here's what it looks like. Or if it's coded well, you can rely on the default or hope the default can parse it. Because time is sort of incorporated in most data observations, it is recommended that you store objects using this POSIX format rather than this as.date format. It operates much the same. If you don't have times, it doesn't necessarily matter. But if you do, obviously, and you code it as date, you're going to lose this information. In this case, you can see when we said, hey, here's this character string as POSIX, we fed in the format that R was already looking for: year, month, day, hour, minute, second. It guessed on time zone because my computer is in the Pacific time zone. And so it said, hey, I bet this is Pacific daylight time. Again, you might want to watch out for that if you don't want it to automatically fill in a time zone. Just like we use those percentage signs to specify the format, we could similarly do something like that with year with a POSIX type time. So in this case, you have 2507-2016. Then we have hours, minutes, seconds separated by colons. And so in this case, we're saying, hey, 2 digits for D, 2 digits for M, 4 digits for Y, separated by these percentage signs. And then we have H and M and S, and there's a colon each between those. And if you say call as POSIX CT on that, you end up with again, POSIX CT object. To prove it, we can call class on TM2. And in fact, it is a POSIX class object. You can, I mentioned that it auto-filled in Pacific time zone. So as it shows in the course materials, if you wanted it to be not Pacific time zone, we could say like Eastern Daylight Time and specify that. And if we call class, then you run TM3. Oh, that didn't work. Oh, I forget. I remember why. You have to specify that as a separate setting. So in the as POSIX call, if you call TZ equals and then use a character string for a time zone like EDT. I didn't know Eastern Daylight Time. I didn't know PDT. Now let's try GMT. We know that works. It's thrilling television here, I know. No, that should work. Warning message. Let's run again. All right, we're good. So now it in fact says, oh, okay, used to call it Greenwich Mean Time, so GMT. All right, well enough. So I don't like using the basic date functions in R. I think they're cumbersome. I don't think they're a lot of fun. I really like using LubrDate. So we already loaded LubrDate. Let me show you how it works. So we create this sample date object again. Now, LubrDate, instead of requiring you to come up with like a fancy character string to parse format, actually just has a separate function for each order. So for instance, let's say you're feeding in days in YMD order or DMY order. Well, LubrDate has a function called YMD, and it has a function called DMY. It also has a function called MDY, and it has a function called YDM. They're all essentially the same function. They've just created these wrappers, but it's kind of intuitive because you can say, hey, I have a set of character strings and I've stored them in day, month, year format. So February 23rd, 2020, call DMY on that. Oh, that didn't work. Oh, it didn't work because the 23rd month, sorry. So let me reverse that, February 23rd. And in fact, it then stores that as February 23rd. So it's kind of powerful. I think it's also intuitive because rather than remembering like the special character string format, you're just like, uh-oh, I have YMD dates. I should use the YMD function, or I can flip that around and use it in whatever order I want. So we'll just do that on our sample underscore dates. That's in YMD format. And in fact, it created a bunch of dates like we wanted. Let me show you a couple of cool features of this. It can also, once you've encoded that as a date, you can pull out different elements of it. So if you call year on that sample dates lub object, it just grabs you the years. If you call month, it grabs you the months. And if you call day, it grabs you the days. So you can pull different elements out, which is kind of useful. Try this with different order, right? Again, month, day, year, sample dates lub2 is created using the MDI function, and in fact, LubrDate handled it. So this isn't doing anything different than the actual base R. It's just Hadley Wickham and his friends took all that base R stuff and rolled it into some nice packages that make life a lot better for the rest of us. So there's a few sample codes in the course materials here that shows using different functions for the same date, but in different orders, and you end up with all the same things. All right, let's try, I'm actually going to skip the time and time zones thing. I just want to highlight it. Essentially, there's the same set of functions you might expect. So just like year MD, you can call year MD underscore hour, or URMD hours minutes, or hours minutes seconds. That's kind of a nice feature because you don't always have like data to the second. You might have just hours or just minutes or something like that, and you can parse any of those formats, which is kind of nice. And similarly, you can specify time zones. Again, it's all functionally just calling as date or as POSIX. It's just a little bit more user friendly. A couple other tips I want to highlight. I'm going to paste in the code chunk from the course materials where we load LubraDate, or ask you to reload it. I'm going to load dplur, and I'm going to load readr, which is just a convenience function for reading in data. I'm going to use read_CSV for the from the like your course GitHub project page. I want to highlight, oh, that didn't work. Oh, I did not add these data into my, it's not in my course folder. Let me see if I can show you a workaround real fast. I can't. All right, so I'm gonna have to go find these data, and I will report back with a second video. But if you are already tired of this, the second video is essentially just some more details about using LubraDate with times and time zones, so you could probably rest easy that you know just about all you need to know and move on from there. All right, thank you, and I'll be back with a little bit of an addendum when I find the missing data. Thank you.